Yes, Michael.
May I go to the bathroom because my throat is really clogged up with a lot of stuff that is draining from my head down.
Okay, I don't need specifics. I just need to understand you get a mark for it. So you need to go, and then when you come back, get a mark sheet and fill it out. All right, 2.6, distributive property. Okay, distributive property, probably the most, it's right, if it's not the most important, it's right there with it, okay? The most important property that we will learn this year, okay? We've already talked about it. We talked about it in 7th grade. We talked about it in 6th grade, okay? So it shouldn't be just a total new concept to you, but it is one that we need to obviously probably review a little bit, okay? Now, where most of you struggle with the distributive property.
Pardon the interruption. At this time, we need all students who need to have their picture taken today to please come to the cafeteria at this time. All students. Thank you.
All right. Where most people have problems with the distributive property is at the end when you're supposed to simplify it, okay? Obviously right here, we can't take and put x plus 4 together because they're not the same, okay? That goes back to our similar terms, like terms. Need to remember those, review, we need to think about those as we're going. So what we have to do here is we have to distribute the 3 to both things inside the parentheses, okay? Now, if there were 10 different terms inside the parentheses, you would have to distribute the 3 to all of them. And what it means is this. That problem and this problem are exactly the same. Okay, let me make that plus sign a little clearer. Okay, the 3 times parentheses x plus 4 is equal to, when we use the distributive property, which means we're going to distribute the 3 to everything inside the parentheses, it comes out to be 3 times x plus 3 times 4. Now, the actual algebraic way to express this is this. A times parentheses b plus c is equal to a times b plus a times c. Okay, that's the algebraic rule. Okay, obviously the one that I showed you is the one with the numbers involved. Okay, because I know how, when I was growing up and I was in school and they would do the algebraic way, I'd be like, oh wow, how's that? What's that? I don't understand that. Okay. Now, the way we looked at it last year, somewhat, we spent quite a bit of time on it, was when we had something like this. 3 times 5 plus 4. Okay? And, you always ask the question, well, why can't I just put the 5 plus 4 together? Because I said you got to know the distributive property because you're going to have to multiply it by things you can't put together. Okay? And what we did last year is we did this. Okay? And then we worked it out. We said 3 times 5 is 15, plus 3 times 4, which is 12, which is 27. Okay? Now, obviously here, right here, the final one of that is 3x plus 12. That's simplified. Okay? That's as simple as you can get. You cannot put together 3x plus 12. You can't say that's 15x. Okay? You can't do that on that problem because they're not the same terms. Okay? So, let's look at another example. Let's say I throw a negative in here. Let's say I have negative 3 times r plus 4. Okay? Doesn't change. Okay, we learned about negatives last night. Multiplying negatives, we should know our rules. You simply distribute the negative 3 to both the r and the 4. Now, this step here is the step that I will let you you don't have to write that step. If you can see it without writing that step, that's fine. In other words, if you can see that this is going to be negative 3r plus negative 12, okay, and that is negative 3r minus 12. Okay, remember from last year that this plus a negative is the same thing as a subtraction sign. Okay? The plus and negative is the same thing as a subtraction sign. That's why we've changed it down here to the subtraction. Now, I'm not going to count it wrong if you write it like that, but you need to understand the book is going to write it as negative 3r minus 12. They're going to assume that you understand that that's the same expression and that you can write it that way. Okay? So we need to get in the habit of writing it that way from here on out. All right, let's look at another one. This one becomes a little bit different because it has a variable on the outside of the parentheses. It does not change anything. Okay? It still doesn't change anything. That's an X. It looks a little bit like a 4, but it's an X. Okay? And so I'm going to distribute the negative 2x to both things in the parentheses. Okay? Now, here's where people make a mistake. I'm going to go ahead and write this one out. Okay, I'm going to write out that second step. Now, x times x is what? X squared. Okay, so that's negative 2x squared. Okay, minus, I'm going to take this, and what is negative 2x times 8? Do what? Negative 16x. Okay, now, this is where some people make their mistake. That is the same thing as the addition sign. Okay, when I have minus a negative, that's the same thing as negative 2x plus 16x. Okay, so when you have plus a negative, it's the same thing as the subtraction sign. When you have minus a negative, it's the same thing as an addition sign. Now, the reason that is true is because of our definition of subtraction. Let's go back and think of this right here. Okay? Well, the definition of subtraction says I do this. First number stays the same. I change that to addition, and I do the opposite of negative 16x, okay, which is positive 16x. Okay, so these two expressions are exactly the same, and they need to be expressed that way. It's really not considered simplified if you don't do that. Okay? Now, in some of these problems, I think they're telling you to use distributive property, rewrite the expression without, without parentheses. Okay? So, Owen. Yeah, it's second. My bad. I forgot to put that second right there. I left off the second that time. All right. Now, good question by Owen is that we can't put the two together because one has a variable of 2, one has a variable of 1, or no variable. Okay? Anytime we have a variable by itself without an exponent, we assume that it's raised to the first power. Okay? And so you have a 1 right here. You cannot put those two things together. Okay? Simply because of order of operation. All right? Now, all right, let's look at this one. 6 minus 3w times negative w squared. Okay, now it's at the back end of the parentheses. Well, being at the back of the end of the parentheses is the same thing as being at the front end of the parentheses. I still have to do the same thing. I still have to distribute this to both things inside the parentheses. And so that gives me negative w squared times 6 minus negative w squared times 3w. Okay? So that's going to give me in the first group here, what's that going to give me? Brandon?
3.
No. First group.
Negative 6w squared.
Right. Negative 6w squared minus, what's in the second group, Nick? Yes. Negative 3w to the third. Okay? Once again, you have minus a negative. Minus a negative, we've already discussed, changes to an addition sign. So that'd be negative 6w second plus 3w to the third. Now, I have a 3 and a 2. I cannot put those two things together because they are not the same. Larry? Can you write the word? No. You have to, on these, you have to put the exponent. We're not writing it in word form. Okay? Any questions on that one? All right. So, once again, understand that this is our answer. Okay? So obviously it's not the, like we're used to, the one number answer, and then it's all, everything's set up. Now, I want you to try 47. Try 47 on your own. Okay? Try number 47 on your own. 47 says 5 times 1/2 x minus 2/3. Now remember, multiplying fractions or multiplying whole numbers times fractions do not have to have common denominators, so don't try to do that. Obviously, the 1/2 x has a variable with it.
If you have not had your pictures taken, now's the time to go. Thank you very much.
Okay, obviously 1/2 x, we can't put 1/2 x and 2/3 together because 2/3 doesn't have an x. Okay? Yes, you can leave it in improper fraction or fractional form. Yeah. No. So the very first step, keep working on it. The very first step is to take the 5 and distribute it to each thing in the parentheses, which means I have 5 times 1/2 x minus 5 times 2/3. Okay, so that's 5/1 times 1/2 times x. minus 5 over 1 times 2 over 3. Okay, which is 5 over 2 x minus 10 over 3. And we can leave it in that form. Okay, you could have written, we usually don't do this. When there's improper fractions involved, we don't usually do that. Okay, because then it becomes a little confusing what you're doing with the x. Okay? So leave it in improper fraction form. Leave it in this form here. That's the way the book's going to express it. And so that's the easiest way to do it for you as well. All right. Now, let's look at simplifying expressions using the distributive property. Okay? And basically what they're talking about is this. If I have 15x plus negative 4x, okay, I can simplify this. First of all, these are like terms. Okay, they're like terms because they both have an x. And both of them have an x, and both of them have the same variable with the same exponent, x to the first. Okay? So, I can use the distributive property to do this. This right here is the common factor between the two terms. So I can rewrite this problem using the distributive property. Okay? Those two expressions are the same. They're equivalent. Okay? Well, when I see it like that, what's 15 plus negative 4? 15 plus negative 4 is what, Larry? 11. So what I'm left with is x times 11, which is 11x, and that's your answer. That's mathematically why we can combine those like terms. Okay? You do not have to do this step. The distributive property step, this is just my explanation. Okay? You don't have to show me that step. If you want to, if it helps you see things better, then yes, by all means do it. Okay? But you do not have to show me that step of explaining why we can put those two terms together. Let's look at another problem. Fairly simplistic. 4 plus a plus a. Now, for some reason, this is where people get a little confused sometimes. Okay? How many a's do I have? 2. So this would be 4 plus 2a. Okay? A lot of times people will put a squared. No. Remember, there is a imaginary 1 in front of both of those a's. Okay? And so if I was looking at this right here, this is the same thing as a on the outside, 1 plus 1 on the inside, which is a times 2, which is 2a. And that's where I get that 2a. Okay? But now, that is it. I can't go any further than that. I can't say it's 6a. I have to say 4 plus 2a. The other way you could write that would be that way right there. That would be an acceptable answer as well. Okay? So I want you to try number 60 on your own. Do number 60 on your own. Not yet. All right, number 60. Number 60 says 8b plus 5 minus 3b. Okay? Are they going to do that? No, good. Brother Larry, what'd you get? 5b plus 5. That is correct. Okay? 5b plus 5. All right. Everybody go to the board. You're going to go to the board. And I want you to do number 61. Number 61. Yeah. All right, everybody look. Obviously, we're struggling with a little bit on this one. This right here, 3y plus 1 times negative 2, that has to be done first. Order of operation says parentheses, okay, 3y plus 1, I can't do anything inside that parentheses. Then it says exponents. There are no exponents in this problem. The next step is to multiply or divide. I have to distribute the negative 2 to both things in the parentheses. And so that gives me negative 2 times 3y plus negative 2 times 1 plus y. Okay? The plus y we're going to deal with at the very last. So that gives me negative 6y plus negative 2 plus y. Okay, now I can take and combine those two like terms. So that's a positive 1y and a negative 6y. So that would be negative 5y plus negative 2. The plus and negative is the same thing as a minus. So 5y minus 2. And that's your answer. Okay? Now, probably where some of the confusion lies is there's so many parentheses. Okay? They could have done this, but the problem if they would have done this, okay, everybody's going to think that's a minus 2. Okay? And it's not, so that's why they've got to take and then put the parentheses around that to show you that it's multiplication. Okay? Where they would have been better off writing this problem would have been to done this. If they would have done this, most of you probably would have, oh, okay, well, you can do that yourself. Okay? This is multiplication. Two things being multiplied together, you can use the commutative property and flip those two terms. Okay? Larry? Oh, thank you, I did. Okay? So, that's how you do that one. All right? Now, for your homework tonight, we're going 2.6, 26 through 68 even. Okay. Then 70 through 80. And I'll leave it there. I was going to go 86 through 89, but I'm not going to do that. All right, so 2.6, 26 through 68 even, 70 through 80 all. Okay. Next test in here is not this week. We will have a quiz over Chapter 2 tomorrow during class. Okay, so we'll come in and grade, and then we'll do come in and grade, and then we'll do the quiz tomorrow.